All right, for today, section 8.1, our objective is the student will be able to solve problems involving direct, inverse, joint, and combined variations. So we're going to start with a direct variation. And direct variation, if it says it's directly related, that means it's going to be multiplied by something. Example, if you go get order pops at a concession stand, and a large pop's $2, you know that if you order 10 pops to take back for a group, you're going to have $2 multiplied by how many cups you have. So 2 times 10 would be $20. So a story problem might look like this. It might say y varies directly as x. Okay? Then it will give you some information like y equals 20 when x equals 5. Now the first part of the problems, they may just ask you to find out what the constant is. And when you do direct variations, your equation is going to be y equals k times x if it's written in this form. Now, this y and x can be any variables we choose it to be. If this was x and this was y, then x would be first and y would be second. If it was a and b, then this y would be an a and the x would be a b. It just depends on the problem. But the k is the constant of variation. That's what the constant's going to be the same throughout that whole problem and all the information that's given to you. So in this case, the first thing they might ask you to do is just solve for k. So when we solve for k, we simply set it up. So when you write this problem, y, the varies is your equal sign, and then we always have our constant. Directly tells you that it's multiplied by the next term after that, which in this case is x. So we can now write this problem, 20 equals k times 5. We can divide by 5, and we now know that in this case, k is equal to 4. And so that's our constant of variation, if they ask for that. Now when solving these, there's more than one way you can do it. One method is find k, like we did on this. We found out that k was 4. The second way is we can use proportions. So I'll go through a problem and show you both ways you can do it. So let's keep this same information that we have here, but we're going to add to this find x when y equals 60. Okay? Now, the problem could be find y when x equals something. They can vary that depending on the problem. So we can do it like we did here. So the first thing we do is we solve for k. And so again, we'll just do the same problem. So 20 equals k times 5. Divide by 5. And so we get 4 equals k. So now we know what our constant is. So our equation for all of these problems would simply be y equals 4k. Excuse me, 4x. So now we plug in the rest of the information. We know that y is now 60, so we plug it in. And we solve for x, so we divide by 4. And we get 15 equals x. So that's one way to solve this problem. If we solve for k and then use this. Another way we can do the same problem is we can go through the problem and use proportions to solve it. Because remember, when you have proportions, you cross multiply it to solve. So I could write this as y1 times x1 equals y1 times x2 equals x1 times y2. So we simply cross multiply to get a proportion. They have to be equal. So if we go back to this problem now, we're going to use this proportion. So our y1 is the first y that they give us, which is 20. Our x1 is the first x that they give us, which is 5, equals y2, our second y, which is 60, and our second x, which is the x we don't know. So now we cross multiply, and so we get 20x equals 5 times 60, 300. Now we divide by 20, and so x equals 15. So you get the same answer either way, and I don't care which method you use, it's just two methods to do the same type. A lot of you will like the proportions for direct variations. Where it can kind of get confusing is in some of the other problems, and all the other problems we can set up and do this way. So this would be a direct variation. The second type we're going to look at is a joint variation. And a joint variation is simply when it's multiplication by more than one term. And so y equals k x z. So an example of this might be, let's say that I'm going to change the variables so we don't get locked into the y and x and z. So I'm going to say A varies jointly as B and C. And let's say A equals 40 when B equals 2 and C equals 5. All right? Let's find A when B equals 6 and C equals, let's go 20. All right? So using this equation, in this case our y, remember our formula, A is our first one. So A equals, and then it's always our constant. Jointly tells us that it's multiplied by more than one, so times B and times C. So again, we have two ways we can do this. We can find K first, or we can use proportions. So let's do it this way the first time. So we know that y, or in this case our A is 40, K, and then our B is 2, and our C is 5. So that would give us 40 equals 10K, divided by 10, so 4 equals K. So we found our constant. Now we go back to this, and we're going to find A, so we don't know what A is, but we do know that K is 4, our B, our second B is 6, and our second C is 20, and so A equals 4 times 6, which is 24, times 20, which would be 480. So again, this would be doing it by solving for K and then going through and solving it algebraically. We can use proportions. In our proportions, it's our y1, which in this case is our A, 40, over x1, which is 2 times z1, which is 5, equals y2, that's what we don't know, our second A, over 6 times 20. So we cross multiply. Let's go ahead and rewrite this. This would be 40 over 10 equals a over 120. Now we cross multiply. So we get 10a equals 4 times 12 is 48, and then 2 zeros. And then we divide by 10, and we get a equals 480. So you can see you get the same answer either way. It's just two different ways of doing the problems. Again, proportions are nice if you can remember the formulas. This is pretty easy because you just set it up, plug it in, solve for k, and then once you have your constant, you can solve the equation. Inverse variations is when it's divided by something. So this might be written, let's go, y varies inversely as x. Y equals 5 when x equals 3. Find x when y equals 32. All right? So again, y equals k divided by x. So again, our first variable comes first. Our varies is our equal sign. We always have the k, and inversely tells me it's divided. So that's where that equation comes from. We still have two ways we can do it. We can solve for k. So let's go ahead and plug this in. So our original thing is 5 equals k divided by 3. And so we multiply both sides by 3. And so we get that 15 is equal to k. So now I'm going to plug that number in to our second information. It says find x when y is 32. So we're going to put 32 in for y equals, we know that's 15. We divide by x. Now, a couple things here. We don't want to solve the equation with x on the bottom. So mathematically, we just times both sides by x. And so we get 32x equals 15. And then we divide by 32. So x equals 15 30-seconds. Now, you can also think of this as a proportion. We can just switch these. It's the same thing. We do it in one step. You can just move the x there and the 32 to the bottom and get 15 30-seconds. You can still use proportions. Let me explain how the proportion works, because our k is y1 times x1, as we got here, 3 times 5. Well, remember, your k is constant throughout the problem, so our y2 and x2 also have to be k. And so now we can set that up as a proportion, because you cross multiply, the y1 and the x1 have to be opposite each other, and the x2 and the y2 have to be opposite each other. Excuse me. So now we can solve this problem. Our y1 is 5. When our x2 we don't know. Our y2 is 32. And our x1 is 3. And we cross multiply. So we get 15 equals 32x. And then you divide by 32. And so you can see whether you use proportions or solve for the constant and then work it out. It works pretty well either way. Sometimes they just ask you to find k, so you have to know how to do this. The proportions, again on the test, you'll be able to do it either way. But what you do run into, and this is where proportions become a little bit difficult to use. And let's just... They'll give you some problems where we involve a combination of the both varies and directly and inversely. So as an example, what if you had a problem like this? Y varies directly as x and inversely as z. And let's say y equals 24 when x equals 6 and z equals 2. All right? And let's find z. Let's find x. Find x when y equals 48 and z equals 3. So these become difficult to do as proportions, and I just find it a lot easier to use solving for k. So when we go to write this, let's go through. Remember, your first variable comes first. Your varies is your equal sign. Then we always have our constant. Directly means multiplied by x, and inversely means I divide it by z. So this gives me my formula I'm going to work with to solve for k. So now we plug in our first set of data. So 24 equals k times 6 divided by 2. Now from here you could multiply it by 2 and then divide by 6, but I would just reduce this. So this becomes 24 equals 2 goes into 6 3 times, so 3k, and we divide by 3, and so k equals 8. So now we have our constant. So now we can go to the equation and plug it back in. So we know that y is 48. We use our second data. We know our k is 8. We don't know our x, but we do know our z is 3. So we multiply. You can do this again two ways. You can multiply by 3 and then divide by 8. I prefer just to think of it as a fraction, 8/3. And so to divide a fraction, you multiply by the reciprocal, so 3/8. Then, over here, the 3's cancel and the 8's cancel. Now you can multiply 3 times 48 and then divide by 8, or you can reduce. 8 goes into 8 once, 8 goes into 48 6 times, and so 3 times 6 is 18. And we found x. So you'll be doing, whether it's direct, joint, inverse, or a combination of them. Again, the keys are your first variable, your equal sign, and then we always have k. And then if it's directly or jointly, it's multiplication, and if it's inversely, it's divided. So your assignment, page 574, 17 to 31 all, you do not need to graph these. I'm going to assume that we know how to plot points and graphs, so when it says graph, just ignore that and just do the problems the way we've done these. So good luck on that.